Hi everyone, my name is Shudi Shao. Today I'm going to present our study of database access performance anti-patterns in database-backed web applications. This is a joint work with my colleagues Zheng Yiqiu, Xiao Yu, and our advisor Guo Liangjing from North Carolina State University. We also work with Professors Wei Yang, Tao Xie, and Xintao Wu. Nowadays, web applications are an important part of our daily life. People can access a website by desktops, laptops, and more frequently, mobile devices. To manage the data of websites, web applications usually use database as a backend to store data and process data access requests. Today's users are usually very sensitive about the performance of web applications. A study has shown that nearly half of users expect a site to be loaded in less than 2 seconds, and will abandon a site if it is not loaded in 3 seconds. So, performance is very critical to the success of a web application. Performance bugs, which are implementation mistakes that lead to execution inefficiencies, can badly hurt the performance quality of web applications. As a result, they will cause companies to lose users and lead to huge economic losses. Performance anti-patterns are common code patterns that lead to performance bugs. Program developers can use them to avoid similar mistakes, and tool developers can use them for bug detection. Since web applications are database-backed, database access performance anti-patterns are very important. While there are some studies focusing on database access performance anti-patterns in database-backed web applications, these existing studies still fail to provide a comprehensive understanding. Some of them conducted literature surveys to summarize non-database access performance anti-patterns, but they didn't systematically report all anti-patterns that exist in the literature. Some of them studied real-world performance bugs to extract database access performance anti-patterns, but they didn't cover all types of database-backed web application. They focused on web applications built on top of ORM frameworks. But there are still many applications that don't use ORM frameworks, such as MediaWiki and WordPress. They always access database by directly constructing SQL queries. We refer to these applications as direct accessing web applications. It is not clear how well existing studies can be applied to direct accessing web applications. So, given the current state of the art, there are still some important research questions not authored. Firstly, since existing studies didn't comprehensively cover anti-patterns in their literature surveys, we want to know what are the non-database access performance anti-patterns in research literature. Secondly, current characteristic studies focused on database access performance bugs in ORM-based web applications to extract anti-patterns. So we want to know how extensively can non-anti-patterns cover performance bugs in direct accessing web applications. And for those bugs not matched with any non-anti-pattern, are there any unknown anti-patterns that can be extracted from direct accessing web applications? So, to answer these research questions, we first conduct a literature review to summarize the current knowledge about database access performance anti-patterns. We conduct a forward and backward citation search with an initial set of well-known publications. After that, we summarize non-database access performance anti-patterns by going through these collected publications. Next, we collect performance bugs from well-known real-world direct accessing web applications and studied all sorts of information related to each bug, such as discussions, patches, and code. We then use the non-antipatterns to match with our collected bugs. For bugs cannot be matched with any antipattern, we further extract new performance antipatterns based on them. During literature searching, we collect 27 papers and one book, and identify the performance antipatterns in each publication. In total, we find 24 database access performance antipatterns. We list all of them in the paper. Future research can reuse our results as the starting point. Note that, among all these collected publications, no one can individually cover all these 24 antipatterns. After summarizing non-performance antipatterns, we collect 114 performance bugs from 7 direct accessing web applications. Among these collected bugs, 107 of them can be matched with our summarized antipatterns. More specifically, they fall into 15 out of the 24 non-antipatterns. The remaining 33 bugs cannot be matched with any non-antipattern. It shows that non-antipatterns indeed cannot cover all database access performance bugs in direct accessing web applications. From the 33 bugs that cannot be matched with any non-antipatterns found in the publications, we further derive 10 new database access performance antipatterns. For each antipattern, we summarize its root cause and fix strategy. Although the numbers of bugs in some antipatterns are small, we believe that these antipatterns are general to all direct accessing web applications. Our investigation further shows that 9 out of the 10 antipatterns can also be applicable to ORM-based web applications. Studying performance bugs in direct accessing web applications help to review new database access antipatterns and improve the coverage of real-world database access performance antipatterns. So in summary, we first summarize and report a total of 24 non-performance antipatterns. Then we collect 140 bugs from 7 popular real-world direct accessing web applications. 107 of them can be matched with non-antipatterns, and the other 33 bugs don't fall into any non-antipatterns. Finally, we derive 10 new antipatterns based on the unmatched bugs. That's all. For more detailed information, please refer to our paper. Thank you.